Hello. Hopefully you can see my screen. So that's my first instructions, to make sure you could see my screen. And yes, let's chat our way out of a paper bag. So I might need to explain this. And as Phil said a long time ago, in before times, I gave a talk at the ACCU conference about coding your way out of a paper bag. And I think I introduced ant colony optimizations and some things like that. And I got people to sign my certificate afterwards, showing that I can code my way out of a paper bag, which I'm very proud of. So one simple thing we can do is, if we're armed with a paper bag and some blobs, we can just set them all walking and out they go. Obviously, this has got nothing to do with machine learning or AI or anything, but at least we've got a paper bag and blobs moving out, and we're done. Perfect. Trouble with that is, it's not very interesting. What would be more interesting is if we added a bit of randomness, and then we're not sure who's going to win. And we can watch this and try and place bets on who's going to escape the paper bag. Now, I've used these demos in talks I've done about random numbers. I think trying to visualize things gives you new ways of looking at things. And it's good to have a go-to problem, as it were. I think lots of us have got favourite code catters to help us keep on learning. So encourage anyone who's listening to find some personal projects. Maybe you've got more time, maybe you've only got a little bit of time, and then maybe you practice catters like FizzBuzz or similar. But spend some time reminding yourself that you like coding and have fun with this. If you want to see some of my other talks, I'm sure you can find them on the internet. Now, the thing about coding your way out of a paper bag is it's a very under-specified problem. But that's really good for learning, because then you're free to do what you want. You can burst out the sides, you can make blobs move in various different ways. There's all kinds of things we can do. As Phil said, everyone's been talking about AI recently, by which they specifically mean some of these large language models, and in particular ChatGPT. So if I've got a certificate saying I can code my way out of a paper bag, can AI do the same for us? Let's see. Whilst I was talking about learning, Phil mentioned I'd written a book about genetic algorithms a while ago, and that's still out there, and I'll mention that later on. I've just had a book published to help you relearn C++. And there's an example in there to help you code your way out of a paper bag, which the demos just now were based on. So just shameless plug. Anyway, back to chatting our way out of a paper bag. ChatGPT. I'm going to be talking at ACCU this year, and I'm going to demo the cat swarm algorithm, which you might not have heard of. So I thought I'd cheat and see if I could get ChatGPT to write my ACCU talk for me. Turns out ChatGPT claims that it's never heard of the cat swarm optimization. If you Google that now, you might find the original paper and discover it was written in 2009. So this is not a new thing. And that's meant I've had to spend time writing the talk myself. So my dream of ChatGPT helping me write that talk didn't pan out. What's the thing about ChatGPT? I guess it's trained on the internet, and it will pull out some things and not others. The cat swarm algo is slightly niche, but you'll have to come to ACCU to see that talk or wait for the video to be online after. So let's stop thinking about cats and concentrate on, well, we need to define some terms. We don't really know what we mean by AI yet. We've seen some demos of coding our way out of a paper bag. And I chat with ChatGPT. I said, okay, can you code your way out of a paper bag? And it argued with me. And then eventually, after some provoking, it says, sure. It often starts with the word sure. There are reasons for that. Here's a simple simulation of escaping a paper bag. And it's come out with a very word-based game. Obviously, I've cut things off the edge of the slide, but you can see the idea. If you type in tear, then you manage to tear your way out of the paper bag and you're done. This put me in mind of, I don't know if anyone recognises Colossus Cave from a very long time ago. I remember playing that when I was 14 and 15 when I first got into computers. And games then were about fun, and I think a lot of AI algorithms have a basis in playing games and having fun and trying to avoid some of the tedium and the boilerplate, and that's a good thing. Some of our inspiration can come from sci-fi stories. So I was chatting with Phil before we kicked off this session. We were talking about Hitchhiker's Guide to the Galaxy, and above all, don't panic. So there's a quote. Each time anyone mentions computers taking over the world or the latest AI thing, I think we need to come back to this. Oh God, muttered Ford, slumped against the bulkhead and started to count to 10. He was desperately worried that one day sentient life forms would forget how to do this. Only by counting could humans demonstrate their independence of computers. So it might be that computers can do things for us, but we need to just practice some stuff ourselves from time to time. And anyway, this is science fiction. In The Hitchhiker's Guide to the Galaxy, if you don't know them, there's a robot called Marvin, and there's something about him being a robot which means he can move around in space, which makes it very different to just chatting to a large language model or interacting with other software AIs. And he attempts to be artistic, and he has emotions. His main emotion is being down and depressive about things. He wrote a little poem. Now the world has gone to bed. Darkness don't engulf my head. I can see by infrared how I hate the night. Now I lay me down to sleep. I try to count electric sheep. Sweet dream wishes you can keep. How I hate the night. Can ChatGPT make up poetry for us? Sure. There goes its starting prompt again, and then the predictive text spews forward. Not having a physical reality to interact with makes us see things differently. Still not defined our terms properly. If ChatGPT is being punted as a type of AI, certainly it's artificial. Is it really intelligent? I think we need to go back to the beginning of computers here and remind ourselves about the Turing test. He wrote a paper called The Imitation Game, which is why the film about Turing is called The Imitation Game. And the point of the test was to see if you could spot which is human and which is the machine. And he reckoned that within 50 years, we'd find it quite hard to spot which was which. Now, here's the thing. I think most of us could actually spot anything generated by ChatGPT really easily now. That's because we're used to the kind of things it spews forth, and it particularly tends to say sure at the beginning of things when you ask it to write code. If you recognise ChatGPT, does that mean it's failed the Turing test? Well, kind of no, it doesn't. I think some people can recognise my writing. In particular, one of the reviewers for ACCU spotted an anonymous article I sent to CV once based purely on the typos that were in there. So if you can recognise something, it doesn't mean it's not intelligent. And I'll just throw this out for discussion later on. I don't know whether we need an update on the Turing test, because people are recognising ChatGPT output. And we need a more general way of deciding whether something's intelligent or not. Just throwing that out there. We start to ascribe qualities to the machines. Oh, that's ChatGPT. It's hallucinating. It's spewing forth this. If you go back and look through the history of computing, you'll see John McCarthy's name crops up again and again and again. And he started talking about some simple machines like thermostats having beliefs about the temperature you need in a room. So just encourage you to go and look at some of the history of this. Now, as a counter to John McCarthy, there's a guy called John Searle, and he said if you've got a set of instructions you follow, which is what's happening with a computer program, it would be like somebody in a room being passed notes and having instructions about notes passed back out again. And the notes he passes out being in Chinese, so he's in effect translating to Chinese or from Chinese. And doing that just by following instructions. It doesn't mean he can speak Chinese or understands what's going on. And you need to be wary and careful about saying that a machine's having any kind of understanding at that point. So this has been a long debate about whether this is AI is intelligent or not. Now, previously talked about can AI replace programmers? Might end up arguing yes, it can today. I'll see what mood I'm in towards the end of this talk. But I think the Chat GPT and Copilot and similars skewed the question round a bit to more, can it actually help us? Is this a useful tool? I mean, maybe some of you already tried using Copilot. You saw me attempt to get Chat GPT to write my ACCU talk for me. That didn't go very well, but that was quite a broad question and it didn't know the algo. Can AI help programmers? Yes, I think it can. But we haven't defined what we mean by AI properly yet. Do you think ChatGPT is a type of AI? It's branded as that. But if you thought about what kind of AI you were dreaming of, what would you really think of? So John McCarthy again described it as trying to reproduce human intelligence electronically. Now, sometimes that means we are thinking in terms of robots. So on the top right, we've got a picture of Lucy, the robot there, which you can look up. And it's really interesting seeing how the guy built the hardware and what fell out of that and how that interacts and works. And of course, some of this harks back to us being afraid of Frankenstein's monster and just getting into fictional stories that put us off. Well, a lot of this has been centered around games like chess and then Go, and we can talk about that more. The reason why the games are really prevalent is they've got clearly defined rules, unlike my attempt to code my way out of a paper bag. And there's a history of computers being used for games. Fact. And I think this is why it keeps cropping up. Now, look, there are lots of different types of AI. I've talked about robots a bit, and I'm not a hardware expert, so I can't go into that. Machine learning gets shunted under AI. And I think a lot of people use the word machine learning nowadays to mean data science or even data analysis, which is frequently about statistics rather than any of this intelligence stuff we're dreaming of, or indeed machine learning. Various other realms like nature-inspired algorithms, like the cat algo I mentioned early on, and chatbots. There's a difference between automating things and augmenting things, so they're both helpful. And I'll tell you something else, that predictive text, if you think about it, is kind of bound up with the idea of what ChatGPT is really doing. I've got a friend, Jez Higgins, who says one day he's going to write a short talk about how to do predictive text and how that's like what ChatGPT is doing. And I'm looking forward to that. Now, this machine learning word, just want to throw on the side, this again is a really old term from the 1950s. And to begin with, it was described as a field of study that gives computers the ability to learn without being explicitly programmed. That's quite mind-blowing, really. That's not how people tend to use machine learning nowadays. They tend to talk about you put some data into an algorithm and it finds patterns for you. I think we've missed a trick there and forgotten what we were trying to do in the first place. Arthur Samuel taught his computer how to play drafts or checkers. I said games being fundamental to this. He said teaching computers to play games is really fruitful for developing tactics that are more appropriate to more general problems. There's, and his approach, and almost all AI approaches, have got this fundamental thing underneath of some kind of scoring function or feedback and some kind of iteration that just gradually moves and learns and changes with the feedback. If you look through Arthur Samuel doing drafts, and then we had chess at one point, and I assume some of you might remember the excitement around AlphaGo learning to play Go. That'll give you more details about the history of how these things have emerged and changed. And we've learnt more about algorithms and computers and how we can teach our computers to play games, and some of the algorithms are slightly more general purpose. So fascinating history there. I'm not going to go into the gory technical details today. Just want to throw out things to remind you things you might have forgotten, and go look some of this up. It's really interesting. Now, the essential nugget of almost all these algorithms, like I said, is we'll have some kind of loop. We'll try a few things randomly, because almost all AI and machine learning algorithms do have this slight randomness at the beginning. Because that allows different things to happen. It appears to be less deterministic, as we saw with the blobs racing at the beginning. The deterministic ones just went up. We knew what was going to happen. The ones moving around a bit more randomly gave a greater exploration of space. And that means that sometimes AI or these random algorithms or stochastic algorithms can find things that you might not have found if you'd tried to do a more deterministic approach. And as it tries some random things, it picks out some of the better ones and then tries again. And many things, including the fundamental models underneath the hood for ChatGPT, do this training thing first, and then you can use them afterwards. But if you're trying to learn about some new AI stuff or old AI stuff, just look for the for loop, find the random, and look for that fitness function or testing. It will be there every time. Now, whether we're using it to take over the world or automate everything and replace people or augment people, still some fundamental similarities going on. We need to stop and think at this point. If you look back through history, we can see machines being built for one specific task to do with, say, farming, and then it generalizes out, and then we end up with more general purpose machines. We can see the same with some of these large language models. Actually, you can turn them towards being a chatbot or various other things. So more general purpose. And computers have gone like that as well. We've gone from having a machine that does one specific thing to be able to program them and do lots of different things. We can automate a lot of things, but automated isn't the same as intelligence. We still don't know what AI really means. And I could give you loads and loads of examples of things we have previously automated, and there's some on the screen there. Bad things have happened sometimes. You know that. You might recognise some of the ideas. If we start augmenting things instead, rather than totally just automating, letting the machines take over, then we can get some good things going on as well. Even just a calculator. You're outsourcing the accounting there, though Ford reminded us to count up to 10 once in a while earlier on. And I need to practice my mental arithmetic once in a while, and maybe you should too. And yet we can reach out to various peripherals to do some drawing on our computer. That's a kind of computer helping us. And it might have some kind of algorithm inside that's helpful. Maybe you reach out to the internet and you look on Stack Overflow if you're stuck on something. And now maybe people are asking ChatGPT instead. If it's helping us, is that bad? Is that good? Oh, just remember Ford saying you need to count up to 10. You need to keep your brain in gear. So we've talked about automation and augmentation, and you could list off loads of things, but none of this is actually AI, right? I mean, even your deployment scripts automatically um, deploying your code, or IntelliSense, which does look and slightly like predictive text, and that can be wired up with some so-called AI. That's not really AI. It's useful, and we rely on our computers to do a lot of things for us. Who's used a compiler or a linker recently? Aren't writing in low-level languages. The higher-level languages means that we're using the computers to code themselves. Well, we're telling them what code to write. So computers do a lot of work for us already. If we're trying to automate what we're doing at the moment, we end up putting a lot of time into self-driving cars. That's had a lot of hype on and off. And I still keep maintaining I would much rather have a teleporter. And we're back to the sci-fi, the imagination there, right? Don't necessarily want to automate what we're doing now. Just want a new world and different ways of doing things and better ways of doing things, possibly. If you automate what you do now, will anything ever change? Maybe a real AI would say, no, stop everything. Let's solve climate change first. Yeah. Augmentation is help, right? So augmentation is slightly different to the automation, as I've already said. Actually, I think if you think about history, when people first start publishing books, there's a degree of outcry. There's a degree of, oh, if women read books, like their brains might explode. And then the internet happens, and there's a degree of, but anyone could post anything and it might be wrong, and this is just no good. And then Stack Overflow, and lots of people complaining bitterly about, well, my students are just copying code off Stack Overflow and they're writing horrible code. But it's useful sometimes to ask a question there, it's still valid. And now everyone's using ChatGPT and Copilot for everything. Well, some people are. And like me, you can try ChatGPT and it might not write all the code for you. And it might be as useless as it was for my cat swarm algorithm, but it might inspire some ideas. Oh, basically, nothing new under the sun. If you read a book, it might have mistakes in. You need to, like Ford, count to 10, engage your brain a bit. Don't go all books are bad. Don't go all of ChatGPT is bad. There's some discernment in here, I think. But ChatGPT, or even the machine learning, or any of the software things, or even some of the robots, aren't the AI I was dreaming of. I really, really love my sci-fi, and I can't find my copy of The Diamond Age anywhere. So that slide's for me to remind me to look for it afterwards. I think if we want to reset ourselves, we need to stop treating ChatGPT as the only form of AI, and that's kind of why I'm doing this talk. I want to remind you there's way more to it than that. So I'm just throwing in the aside about, does AI as software, and then there's AI as maybe in a robot, do to get proper AI, the AI I was dreaming of, does it need that physical body? Maybe. Can you think independently of a body? Could a person exist in cyberspace? A lot of sci-fi stories have like whole brain emulation or uploading your mind to something. And other ones do end up using a robot, but that's about acting, and that's how films work. It would be quite strange to just have disembodied voices. Well, there are examples of sci-fi like that. So, yeah, just throwing in that one. When we're talking about software AI, we're missing an entire part of the story. And a lot of the so-called AI is involved in good things like um, enhancing things that have gone wrong, like your hearing, or in artificial limbs and so on. Though we can go into sci-fi scary things at that point too. If you build a brain, I guess like that point in the Dr. Frankenstein story, the brain goes in the body, put the electricity through it. Will Frankenstein monster come to life and start thinking? Underneath the ChatGPT models is a neural network. There's a little picture of one at the bottom. Could explain the gory details, but there's not time now. Basically, it has some inputs coming on the left and then spews out numbers on the right. Are they really thinking or learning? We describe them as being trained and on learning weights, which means they work out what to multiply the inputs by. They do some adding up, then they send them for another function and get something between 0 and 1 at the end. These certainly couldn't pass the Turing test. If you look at how image recognition algorithms work, they need a huge number of images, whereas a child will learn from far fewer images much more quickly. So even though we've tried to build brains with neural networks, they work very differently to human brains. Still useful, but they're different. There's a degree of, which I've alluded to, people going, I don't like all these newfangled books, or this newfangled internet, or this newfangled chat AI. And sometimes we get described as being Luddites. So I just want to remind us that Luddites are actually complaining about not the machines themselves, it's more about the way they were being treated as workers. And there's a reason why people are talking about ethics in AI. If you look into how some of the data sets are labeled and things like the Mechanical Turk paying really not even peanuts to people who are spending hours labeling the data, there are some human and ethical concerns in the background. But again, I've only got an hour and I could talk about this for days. I just want to throw that out there. It matters. Right. So, can AI replace programmers? I talked about me coding my way out of a paper bag. We let ChatGPT have a go and it came out with a text-based game, which wasn't much fun. FizzBuzz is the traditional way of seeing if a candidate can pass an interview test or not. So, can we get a computer to code up FizzBuzz? I'm going to pull out a point here before we dive into the gory details. There's a book by a guy called Ray Kurzweil that I've rediscovered on my bookcase recently. He describes himself as a futurist. This is like 15 plus years old now, probably more. He was saying that he could see 3 ways that machines were going to be used to do everything for us. He looked at recursive algorithms. If you remember AlphaGo, if you have come across it before, that was a step change from playing chess. Now, you can play chess by recursively looking down all the possible moves, or most of them, and working out what might be optimal given what your opponent can do. Go up the stakes because the state there is too huge, but it is still a recursive algorithm. It's doing a tree search thing under the hood. So that's one way machines have advanced, and it's really interesting. We've forgotten about the excitement over that whilst we've become distracted by ChatGPT. Then there's the neural networks, which ChatGPT and other large language models fall under as well. And then there's this third spike he mentioned about genetic algorithms, and he expected to see them more commonly used. And I think a lot of people don't know about them, but I think they're really neat. So they're much easier to understand, and they don't use as much electricity to train. I'm just throwing that in. So, ChatGPT, write me FizzBuzz, and it chose Python. Does that happen to you as well if you've used ChatGPT? Does it tend to pick Python if you don't specify which language you're after? Just throwing that in. Okay, I will accept it. It has got written FizzBuzz for us, and I asked for the tests, and there are some tests. Pushed it a bit further, said, okay, can we do this in C++? And it dutifully did. I notice here that we've got more test cases for each of the 4 types of fizz buzz, or a number. I'm assuming everyone knows fizz buzz. If you don't, ask me a question later or chat to each other. So that's ChatGPT. That's, like I said, it's a neural network under the hood. The GPT is a generative pre-trained transformer. So someone's done all the grunt work training up this model for you. One moment. It basically takes input, which might not be text. Don't forget you can apply this to images or music as well. The chat bit's just a skin over the transformer. And there's stuff going on with the weightings multiplying and adding up under the hood called attention, which is to do with how significant, relevant nearby things are. And then things either get activated or not afterwards, which gives you a probability of the next word or, well, whatever we've encoded. It always starts with a start token for the chats, which is often sure, and then spews forth the rest, almost like predictive text. But under the hood, there are lots and lots and lots and lots of neurons in lots and lots and lots of layers, which means lots and lots of multiplying and adding up. And that's why it's a deep neural network, because it just goes deep, layers and layers and layers of maths. After you've trained it, you can then tweak it and fine-tune it to make it do specific tasks. And that can give you some of the nuances that you see in some of the online bot assistants that help you if you're interacting with a company or similar. Fine. And then basically, when a prompt comes in, it starts with it's sure, and then finds what words are likely to come next with that context of the prompt or the question that's going on. Basically, multiplying and adding up under the hood. You send in your input, it's encoded, does some maths, and spews out some output. So we've seen ChatGPT. Sometimes, and more than sometimes, it will spew forth code that doesn't compile or doesn't do what you've asked it to do. I'd like to just remind people or tell people that back in 2018, there was a paper published about conditional program generation. There was also using a neural network under the hood, but that checked that the code it generated actually compiled. So I asked this Bayou implementation of it to code up FizzBuzz. Right, hold on to your hats. Are you ready for this? Here we go. Apologies about Java at a C++ conference, but Bayou just does Java. This compiles. Whoop. Does it generate FizzBuzz for us? Well, my Java's a bit wobbly. I can see it making a new integer out of a new string and transforming it back to a string, which seems a bit flappy. I see no fizzes, no buzzes, and no fizz buzzes. So this setup was constrained to ensure that the program actually compiled, but it didn't generate fizz buzz. So that's no good. Whereas ChatGPT did. Though I do think ChatGPT is easily findable on training data from the internet. So I like the dream of this attempt, insisting that the code actually compiles. That is important to me if I'm going to let computer write code for me. So I mentioned the recursion. We've looked at ChatGPT generating things for us and talked a little bit about neural networks at very high level, and then mentioned the Bayou trying to ensure that things compile. Now, I'm going to do some genetic programming. Now, that's the generalization of a genetic algorithm, which does something random in a for loop, picking the better ones as it goes and tinkers around a bit, which I told you earlier was the essence of almost all software AI. So And there's some examples in my book if you want to have a look. And there's plenty of other things in there too. Unfortunately, not the cat algo. Again, you have to wait for ACCU for that one. So, genetic algorithms are driven by a feedback mechanism, which is pulling on the idea of Darwinian evolution. So, fitness helps you survive. What do? We make some random arrays, and in a for loop, we try them. That might involve, say, an array 5 long, shoveling 5 numbers into a function and seeing if we get close to 0 or not. Or depends what you're trying to optimize for. And then we take some of the better ones, twiddle them around, and we keep going until we find a solution or a good enough solution to our problem. So the 2 steps, having set up several things to try our search space, we could, so if we were searching for 5 bits, noughts or ones, we could snap the end 2 parts off one of our arrays and switch it with another one. And then we've got 2 new things to try. We could twiddle a bit from on to off or vice versa. And that's allowing us to search quite a lot of the search space, quite a lot of the possible inputs without brute forcing it and trying everything. And that's the important thing about a lot of these stochastic algorithms. They just allow us to try some of the search space, and then we might find an answer to our problem. What's this got to do with FizzBuzz? Well, instead of an array, I can make a tree. And then I can snap bits of the branches off and swap them over or change a plus sign to a minus sign. If I've got a tree, I've got an expression tree, I've got a computer program. And you can read loads more if you follow up some of the 2 books by Koza, the classic ones. You can do it for more than just writing code. You can do it for symbolic regression and other kind of maths. You can design things. Was genetic programming exactly the same as genetic algorithm? We just start with random trees. Now, if I do this, I can not only check things compile, I can also bolt in the tests I want to pass. And I've stolen Kevin Henny's 8 tests for FizzBuzz because he's much cleverer than me, and these are definitely necessary and sufficient. And they give us the feedback to the AI, and that's something I can't see how to do with ChatGPT or the Bayes thing I mentioned or other approaches. And now I did this in a Python library, and I had to tell it specific functions to use. So I coded up if then else, and there's some horror in here. There really is. If you look really carefully, apart from your eyes starting to melt, you can see it doing things like if x equals x, then if you've got either bars or bars, then you return x. This approach to generating code tends to spew forth lots of bloat, but it came out of valid Python and it passed the tests. So is that better than the ChatGPT? It does give us the possibility of saying, pass these tests and make sure the code's valid. And I think we've forgotten about this. And it's quite cool. But it takes a lot more setting up, to be fair. And I had to write the tests up front. When I say I wrote them, I just nicked them off Kevlin. Maybe it's all right if you don't get all the tests up front. That's how we often develop code anyway, isn't it? You try something and then you talk to your users and then you go, oh, I don't quite like that, or we need it more like this. And you have that business people in the loop, and maybe we need humans in the loop as we get code developed by computers. A human in the loop is a phrase which again has been misappropriated to mean people pay peanuts to label data. It shouldn't be like that. It should be collaborating with the machines. So the Python framework I used wasn't using the abstract syntax tree. And there are things out there about playing around with LLVM and doing things with C++ if you're interested. And maybe I'll get round to that one day. I discovered a book on our bookcase about C# programming. There's a chapter in there about genetic programming. So these things have been loitering in the background. And I hope that we don't forget that there's more to AI than ChatGPT. Doesn't mean ChatGPT is bad. Doesn't mean it's good. It's like a book. It's a thing. It does use a lot of electricity, and the GP approach will generate valid code that passes your tests, but it might take quite a while to get there. And as we've seen, the code tends to be bloated and hard to read. But if we cut humans out of writing the code, does that matter? In fact, imagine if you could come out with some behavior-driven development style tests. So the users write those, give an executable specification, send it into the AI, and then see whether it passes or not. That's very different to ChatGPT generating its own tests earlier on. So you've got to see if the code's valid and if the tests work. Just a little daydream. Can our users actually specify precisely what they want? Well, no. But like I said, that's why we do iterations, and you don't get things all specced out up front always. Here's the thing. How many of you have actually heard of genetic programming before? If you've heard me speak before, you probably have. But I think it's quite niche. Whereas almost everyone seems to have heard of ChatGPT. Now, why is that? The genetic programming took an amount of technical skill to get up and running. Whereas that chat interface on the internet, anyone could use it. So it's very low bar of entry to actually get using this, even though there's all this technical stuff happening underneath. Genetic program does not generate readable code. ChatGPT can generate readable code, though it might not compile. Just saying. I can force a genetic program to come out with working code that passes specific tests, because that's part of how it's set up and how it's been designed. But we can't do that while we're just chatting with a large language model. Also, the genetic algorithm approach, because it's trying random things out, can actually innovate. And I mentioned this being used to design circuits. On Wikipedia, there's a picture of an antenna it's designed that a human would never have come out with, but it solved the problem using minimal amount of resources and metal to make. And it will help us spot things we wouldn't have thought of before as a result of just trying some random stuff. Whereas the large level language models, in a sense, are just parroting. There's a whole concept of a stochastic parrot going on, which we could talk about for hours. I'm not sure that ChatGPT is going to come out with something new, but that's very different to chatting with ChatGPT and it helping, right? Just, yeah, different types of AI. And I don't think any of them are actually intelligent, to be honest. Look, all of this dates back to the beginning of computers. I mentioned Turing earlier, John McCarthy yet again. He invented Lisp with the dream that the program could then be manipulated by itself and change itself. Lisp was designed in order for computers to be able to program themselves, give them the initial code, and then poof, off it goes. As a side effect, we see things like garbage collection invented and things. It's amazing how often when we invent one thing, we end up with all these other side effects and we learn other things. Lisp is quite good fun if you're into that kind of thing, but I don't think it's now writing all the code for us in the whole world. So maybe that little pipe dream didn't happen. Again, so just let's start winding things up. We've talked about the difference between augmenting things and totally automating things. You need to watch out for what you're automating. But like I said, CI scripts and some of the automation we do, code that generates boilerplate code for us is great. Compilers and linkers are great. Much rather that than down low level typing in assembler myself. We can get computers augment or help us as well. Now, whether it's algorithms or actual AI, don't know. Computers can be good sometimes. Why are we doing this? That's what we need to keep asking. Just because you can doesn't mean you should. And I do have a concern about the amount of electricity we're burning through with these large language models. I noticed recently Microsoft has been trying to introduce small language models to try and streamline this a bit. So watch this space. Let's see where it goes. I talked about the human in the loop idea earlier, and I had a quote from Norbert Wiener, who, who's written some stuff a long time ago that steered how some of our thinking works. And he introduced the idea of cybernetics. And that's the point, right? We are not actually Borg. We haven't been taken over by the collective. We are humans in the loop. We're supposed to be steering. We're meant to be piloting things. Co-pilot's meant to be a co-pilot. So let's not brainlessly walk into something. Let's step back and count to 10 once in a while. Remember, there are other kinds of AI, or if you'd rather, just different algorithmic approaches that have different pros and cons. I talked about AI being used to help with physical problems we might have, and just Stephen Hawking was wonderful, and he was relying on lots of computers in order to communicate. And yes, I've thrown in loads of sci-fi like pictures here as well, because I can't help myself. We can do good things with some of the augmentation and make the world a better place if we concentrate on the right areas. And actually, we can make our code better too. You might not think of mutation testing or property-based testing or fuzzers as being AI, but they've got that essence of the for loop, doing something random and then nudging things towards a fitness function that underlies almost all software AI. And maybe some of you are using mutation testing or fuzzers from time to time, or have heard people talk about property-based testing. This can make your code better. This can find out problems with your tests. So embrace the random, embrace the for loops. Let's let the machines help us. Is it AI? It's not the AI I was dreaming of. It is useful. We don't know what AI is yet. I haven't helped us at all. I kind of want to say almost implemented. There's this thing in AI, and the same has happened in philosophy. As soon as a discipline's invented, like image recognition, say, falling under the AI umbrella, it ends up with a new name and becomes a new specific discipline. And the same has happened with philosophy. As you get physics branching out from it or chemistry branching out from it, you get a new discipline. So I think what's left as AI is all the things we haven't quite got some anywhere. We're still playing with. And I think the chat GPT and large language models are going to break off as a separate thing. And maybe we'll just talk about chatbots at that point. Where AI will go next, I don't know. But I'm sure underlying most of this is playing games. If you look at how things are developed, how things are trained, and yeah, playing games is fun. Can AI replace programmers? Yes. Though it did take me 2 or 3 days to get the deep framework to generate the code for FizzBuzz, so that might not be particularly efficient. But I mean, I don't know whether AI would ever write its own language and whether it would have come out of Lisp. And it's cool to use Copilot things to generate code. Okay, maybe it doesn't compile and you need to still engage your brain to do that count to 10 and think. Yeah, we can use it to tune our tests. It's a tool, it's a thing. And sometimes it's useful, sometimes it's not. But we need to be involved in the loop. I think we can't just automate things and sit back. We need to be able to steer things, turn things off if we don't like them, change our minds. So what's up next? Where does this go? I put it to you that large level language models are a fad. They can be loads of fun. It's quite nice getting ChatGPT to rewrite something in the style of a pirate or whatever. I mean, why not? It's fun. I was thinking, like, where could you actually go? Could you make computers properly program themselves and take over things? Now, my background is in mathematics, and something called the Hilbert's program was started ages ago, trying to work out if you could prove automatically all of the maths that there was, or all maths that's true. And we end up budging into Gödel's incompleteness theorems, which you've probably heard of. The bottom line is you can't completely cover everything and end up with something that's not inconsistent. You've got some logical limits on what's possible. And maybe you could draw an analogy of the halting problem or NP-hard problems or similar. There's the whole mathematical limits on things going on. And the people are still generating mathematical provers, automated theorem provers, which is loads of fun. And they tie in with some fundamentals about trying to prove that your code's correct rather than using software to test if your code's correct. Again, this could be a long chat afterwards to talk about code proof rather than code testing. But higher order logic is undecidable. So we've hit Gödel's incompleteness theorems here, and human assistance is required. That's a quote from the automatic theorem prover paper, which I quite liked. Humans in the loop again. Look, it's all we can try augmenting our coding, use the internet. I think we can't. I think we probably are going to hit. We have hit some mathematical constraints about all the things we could completely automate away. This is a newer thought, and I'm not sure I can prove this, but it feels like there's a connection there. Yeah, let's use ChatGPT, but don't forget the other types of AI. Let's try talking to each other rather than just chatting to the internet sometimes. Let's help each other out. Hopefully, you're having fun whilst you've been at the conference and you've been talking and interacting with each other a bit. And hey, go old school, read a book once in a while, have fun. Maybe you can code your way out of a paper bag or code up a game or something. It's my first book Phil mentioned. Find it, play with it. I've got talks based on some of the chapters in there. And as I said, I'll leave this up for a moment. I've been writing a C++ book. There's one chapter in there to help you code your way out of a paper bag, which plays around with the random numbers, trying to just help people get back up to speed. If you've seen some stuff you're not aware of today, if you've been left behind, there might be something useful there. Have a look. So there's one code that's active for 3 months for my book, or there's another code that lasts forever that you can use for any other books as well from Manning. And that is all I want to say. I'm sorry, Phil, if I didn't go through the details of how things work properly, but I just wanted us to step back and go, hang on, AI is not the same as large level language models. The recursion and the genetic algorithm approaches are other prongs to that. And all of this is just about for loops with some randomness going on, really. Perhaps we're better off just calling them algorithms. That's my thought for the day. Thank you for listening.